Hello friends, this is Dan. Welcome to my YouTube channel danjunk-DIY on projects related to do it yourself. This is my collection of junk items, and today I intend to create a useful item using some of these items which are partly functional, broken, defective. Okay, and so I intend to start by identifying the things here. So let me go for this particular thing. Seems to be a bit in a working condition. So this seems to be a power supply board or a control board for a refrigerator, I think. It has two relays. There's a transformer. Probably this transformer, this relay is switching some AC load. So probably this bigger relay is switching a compressor, and the smaller one maybe for a thermostat and other subsystems in a refrigerator. And there is an IC here. Probably this is a timer sort of thing, programmed, probably defective, and tapioca have been tampered many a times for repairs, probably in the past. So this may not be working also, I'm not sure. The capacitor, and there are certain items on the back side of this board. Let me see what is this. And okay, now these are 4 rectifiers. Probably it's a bridge rectifier for a DC supply, and this is 7812 regulator. It's a 12 volt regulator, and this is 7805. It's a 5 volt regulator. So that means this board is having a dual power supply, and one is 12 volt and 5 volt. 5 volt probably powers the logic circuit related to this IC and other controlling inputs, and the 12 volt, as per my assessment, it is driving these 2 relays, power source for functioning of these 2 relays. The relay coils are driven by 5 volt, and the relay contacts switch to 20 volts for the load side. So there are 2 loads, one probably is a compressor, and another may be a thermostat associated subsystems. So this part seems to be good. So I intend to use this as a power supply, and I will use this relay portion also, since it's readily built and I have to make some connections, and I can utilize this portion. And of course this regulator and bridge rectifier. This IC portion, since we don't have any data, I do not have any data on this one, and this seems to have been tampered also. There is no point in working on this. So this almost 75% of this board probably appears to be working. I will select this item. This number 1 item I am going to select. Second, I want some components and other things which I am going to take out from this old circuitry: diodes, transistors, switches, capacitors, opto isolator is there, an optocoupler. So depending on the value which I require for my project, I can take out these things and utilize this. Okay, this will be useful to me, and I will be needing some other item. This is a cable with some device here. Seems to be a black thing here. This is an infrared receiver, I think. This has to be an infrared receiver. So 3 wires are coming out: ground, probably supply, and a signal output. So exactly I do not know for which equipment it was being used, and it is lying with me since a long time. I am going to use this one. Infrared sensor or infrared receiver. So then let me look for something else. There is a remote control broken dismantle remote control is there. Since I am going to use an infrared receiver, I will be needing infrared transmitter also. So I will use this diode, infrared transmitter diode. Probably mostly these things don't go faulty, so this will be useful. So I'll be using this. There's another remote control also is there, so depending on my requirement I'll be using one of these, depending on the serviceability. And some more items I'll be needing, more components. I have an option of taking out from this old board which appears to have been used for a UPS or a inverter supply. This has a plenty of components, plenty of resistors, you can see it, ICs, resistors, capacitors and variable resistors, relays, connectors. So I can take out this from this board and use it for my project. So this will be a useful item. So basically I'll start with this one and I'll start working on this and proceed further, and depending on my requirement I will select some more items from my junk collection. Well, we have identified the desired items, so let us work on the first item that we have identified, that is the power supply board. So let us proceed up. I am going to remove that IC which is no longer required. This is the IC which we don't need. Right now let us check this power supply by powering it up. So this should be able to give us 12 volt and 5 volt, and meanwhile please note that 5 volt is for signaling purposes, that is for creating a logic input, and the 12 volt is used for driving these two relays. I think earlier I might by mistakenly have told that relays are being driven by 5 volt, but not so. This 12 volt is driving these two relay coils, okay, and each relay is driven by a one transistor circuit, switching transistor. This bigger relay, that is that blue relay, is driven by this transistor, you can see it, this transistor, and this black relay, that is a smaller relay, is driven by this transistor, the second transistor, whose base inputs are terminated at the IC sockets here at the IC mounting place. So pin number, particular pins, 2 pins are connected to this IC which I have removed. So I will be utilizing these 2 points for my switching this relays. Okay, I will be utilizing the inputs to for transistor 1 and transistor 2, which switch these 2 relays, and I am going to use the 5 volt supply and 12 volt supply. So basically I should ensure that this supply is working, relays are working, and the rectifier is working, and it is giving 12 volt and 5 volt, capable of giving 12 volt or 5 volt. Okay, so let me wire it and test it further. I am taking out this connector on this board, junk board. I have taken out. I am going to use it here for this board. Okay. Well, my power supply is getting ready. I have added a connector taken out from the junk item. I removed a connector from here and put it here. This is the connector socket. Okay, now this brown and black is my phase and neutral input to the transformer, AC input, and this is relay 1 and relay 2. This black and red is the relay output of switched output of this blue relay. This is a heavy duty relay, higher current rating, the smaller current rating. This can take up to 3 amps, the smaller relay. The bigger one may take up to 10 amps. Okay, so I have 2 switched relay outputs. This is the AC input. So this will be in AC and the switched output, neutral and phase, neutral and phase. Okay, now I am using another junk item, that is a broken plug pin or a holder. I have taken out these pins from a bulb holder. Okay, I am using this particular terminal brass thing for terminal connections. One I have already fixed it here. One I have already fixed it here. This is my ground point, so that I can connect external ground connections to here. Okay, I have threaded it to the base of the board. So this will be the positive terminal for my 5-volt supply, so that I have access to 5 volts for my other circuitry here. 12 volt if I want, I will take it directly from the base, because I don't have space to put another terminal here. There is no space to drill it. So this is another junk item from a broken bulb holder. I have taken out this one. So gently I will tighten it, then I will solder. This is a brass thing, I can solder it on the bottom, so that I can get a 5-volt supply access from the top of the board. Otherwise, for each time I have to make a connection at the bottom. Right, I think that would be sufficient. Okay, this will be my negative. I'll be marking it. This will be my negative terminal, and this will be positive. I'll be marking it with a red marker at a later stage. Okay, right, now I have my power supply almost ready. I can add an indicator also, that I will try to do it. So this will be my AC supply to the board. Then I should be able to get ground and 5 volt here, and another terminal somewhere should come here. So with reference to ground to that particular point, I should get 12 volt. So I have a dual power supply ready almost. So let us test it. I will make basic connections, make a test setup, and I will show you, so that my power supply board should be in a working order. Right, well friends, now our power supply has been rigged up, and I used a connector. So this connector in fact belonged to a old circuit which I had shown you earlier. It was here. I took it out and used it here, so that I can make a multiple connections using a single connector. Okay, so at any time if I want to do, I can retrieve it and reconnect it also. So now our power supply is almost ready. Right, Now I'm going to summarize you what exactly I have done so far. So just have a look at this circuit. Briefly I will explain. So what has been done. So this is the transformer which I have showed you earlier. This is the transformer here. Okay, this is the bridge rectifier. This is 1, 2, 3, 4. These are the rectifier. This is the bridge rectifier system. Capacitor filtering, 12 volt regulator, 12 volt and 5 volt. Okay, 12 volt and 5 volt regulators. I have 12 volt power supply DC here, 12 volt 5 volt power supply DC here. Next, these are the two relays, blue relay and black relay. So you can treat anyone as a blue and black here, and they have associated transistor switching circuits. So these are minute transistors, SMD, surface mounted devices. You can see it here. These two are the transistors. They are linked to these particular pins here. So transistor 1, that is Q1, Q2 you can call it. So logic input 1, logic input 2. So whenever this input is driven high, this relay activates and this closes, and the lamp connected to 220 volt lights up. Whenever a logic is applied to transistor number 2 through this one, this switches, the relay on, and both use common supply 12 volt, and they switch another AC circuit, another lamp 2 lights up. So this I am going to show you. So this is the basic things. Okay, how I am going to create a logic output. I use this 5 volt supply and give it to this input here using a 10k or 12k resistor. So this is what I have shown you here. I have connected to the 5 volt terminal. So these are the respective inputs. Okay, now let us see how it works. Right, let it be like this. Now I am going to power it up. This is my AC socket here, power supply, and lamp 1, lamp 2. This is my AC mains, relay 1 and relay 2. Okay, there are two lamps, so I should be able to light it up. So I have powered it up. Now I should be careful when handling this. Now let us apply logic 1, let us say one of these inputs, see what happens. Right, so relay 1 is active. Right, relay 1 is active. I think this probably I activated the relay, blue relay. Okay, the blue one, which is having higher ampere rate, and the second one is, let us see what happens. So this is the second relay, this LED lamp. Okay, just to differentiate, I have used two different lamps. One is the incandescent, that to filament type 40 watts to 20 volts. This is for relay 1 and this is for relay 2. Right, if I need, I can switch both the things simultaneously also. Okay, you got it? That is my option. Right, so this is my basic interface, and my power supply system is ready now. Now I have to interface this system with an external signal source. That is, in my case, it is infrared receiving system. Right, so I'm going to interface with this receiving system. So first let us fabricate that particular thing, then we'll come back to this. Okay, right, keep watching. Okay, let us understand the receiving portion, that is the input to our relay board. So there also we have one transistor. I am explaining for one relay only. Actions are similar for both. Okay, one transistor, and so this has a relay coil, right, and we have this is at 12 volt DC. This is my ground. and this is a biasing resistor for the input for the switching transistor, and this is my terminal in question where I am going to connect these two. I intend to connect the infrared output to the input of this circuit board. Okay, like this. This is my input connectivity, connecting wire, right, which switches this relay, blue relay, right. And of course here I have a relay contact. Let it be like this. This is my 220 volt AC terminal, right. And this is my lamp load. So how this works: when a voltage level 1 appears here, or this point, when it goes high, this transistor switches and relay activates. This contact closes, and the circuit is completed and the lamp lights up. So this is my requirement. Now here what problem I am facing is, if I connect this infrared thing directly to this board, I have a logic level high available when there is no infrared transmission. Even though there is no infrared transmission, this remains at high always. Okay, so if I connect it here directly, right, if I make a connection like this, so when this goes high, the switch is on and lamp is always on. But that is not my requirement. My requirement is, as and when I activate my infrared transmitter, okay, then only this should switch on. In this case, even though I am not switching it on, because of the inherent properties of the circuit, if I connect it, this switches on and lamp lights up. Okay. Now, to solve this problem, I need one intermediary circuit in between. I am going to make one circuit and insert in between this infrared thing and the receiver and the relay driving system. So this, instead of connecting directly, I am going to connect it through another circuit. Intermediate circuit is a small circuit where this voltage levels are inverted. See, now suppose the voltage level is 1 here, that is high. Okay, this becomes low. That is the present case. When this is high, this becomes low. Sorry, when this becomes 0 here, this won't be conducting. That means the normal condition, this won't be conducting. Only when the infrared falls on this one, this goes to 0. Earlier it was at 1, now it goes to 0. When this goes to 0, this point goes to high and this switches. This is what I require. Therefore, this circuit is known as an inverter circuit. Okay, inverter. This is a logic inverter. So now normal symbol for this one is like this, inverter gate. When 1 is given, voltage is 1, here it is 0. When it is 0 and this is 1. So this is what I am going to devise it here. How I am going to do it? Watch it. For this, I have option of using one single transistor or one IC, which I have extracted from a junk circuit board which was defective. So fortunately that IC was okay. That IC is 4069. That is an integrated circuit. This contains 6 such circuits, that is hex inverter. They call it hex inverter. Okay. Well, I have integrated that digital inverter circuit which we were discussing. onto this relay board. So I have used the IC 4069. It was retrieved from a defective circuit board. Fortunately, this IC was in a working condition, and I have integrated this board with the power supply and the relay system. And for this project I will be using a single relay only. The other relay I will not be using, so I'll tie it up. I will not be using the other relay. One relay is sufficient for me for this project. And this is the integrated circuit which interfaces the infrared receiving system. This black cable is the cable which is linking the infrared receiving system. This one, okay. I could have cut this cable and put it mounted this receiver on this board itself, but for flexibility and for my installation requirements, I have maintained the cable length. Okay, this cable is linked to this digital circuit which switches this relay when the infrared signal falls on this receptor. Okay, so this is the complete assembly now. My whole assembly is ready. Now let us test it, and for safety purposes I am using the old credit card as an insulator to cover the back portion of the printed circuit board, because this portion is high voltage, it is 220 volts. So while working I should not accidentally touch it, especially when working on the test bench. So to prevent any accidental short circuit, I am using this old credit card, which is a plastic sort of thing, as a insulator. And let us decide the destination, I mean the end product of this project. Still I have not decided what I am going to switch. First I have to make systems and subsystems which are in working condition, integrate them together so that some useful thing has been some useful item has been fabricated. I mean, we are going to end up in doing some useful item. Okay, so that is the intention, right? So keep watching. Well, I need a gravity switch. I'm designing a gravity switch. So this is a broken relay. This is a broken relay coil in the assembly, and this is the switching portion. No, this is the contact. Okay, so I have used this broken relay, a portion of the broken relay, only the contact portion. These are the contacts. So this I have portion I have taken, and I have attached a tube, plastic tube. I have fixed onto this tube. Okay, so this I am going to use as a gravity switch in my project. I need a switch. When it is tilted, it should go on. When it is tilted, it should go off. So this is one of the ideas I have put it into practice using these junk items. So this is a sort of brass piece, bit of weighty thing. This has nothing to do with the thing, only except for the weight. So when it drops, this contact closes here. These two contact close. Okay, thereby creating an electrical circuit. Well, this is my homemade some sort of gravity switch. Okay, this is required for my project. As I told you, when I tilt it vertically, and in the vertical position these two connections should be made, and the electrical circuit should be completed, and when it is tilted horizontally the circuit should break. So these are the contacts. Make, break, make, break, make, break. So this is a homemade switch. This is a broken relay assembly, a plastic tube, wires, and I have clamped it. This contact assembly I have clamped it with the tube, and so it is firm, it won't create any loose contact, right? So this is the switch. I'm going to use this in the project. Well, my switch assembly is ready. I have linked this homemade switch with the infrared remote control. Now I have powered up that power supply board and relay system, and let us check whether this works or not. Right? Off, on, off, on, off, on, off. So this was my requirement. So now our project is almost ready. Now the question is where to deploy this and test it. Well, let us deploy this system practically and evaluate. So where shall I do it? Where shall I deploy this? Yeah, why not in toilet? Surprised? Yes, we will try this in the toilet. Okay, in the washroom we will try this experiment and see what happens. Well, I have deployed that remote control, infrared remote control on the toilet cover in my house. I will demonstrate you how this is going to be used. And this is my relay control unit. It is powered by AC there. And the black lead is leading to the infrared sensor, and there is the exhaust fan. That is my exhaust fan. Well, my intention is to activate the exhaust fan as and when the toilet seat is lifted. Here I am going to lift the toilet seat cover rather. Here it goes. You can hear the sound. The exhaust is on. You may not see the rotation, but you can make out from the sound. After using the toilet, I will close. After flushing, I will close it. Right? The exhaust has stopped. So this was my requirement. This is just a concept to demonstrate that an exhaust fan can be remotely controlled using the infrared receiving system, and for which I have used most of the items collected from my junk. I took a power supply board, worked on it, made it operational. I added switching circuit, infrared sensor receiver, switching circuit. Then ultimately I modified a infrared remote control and installed it on the toilet seat cover. I lift it. Here the exhaust starts. After using the toilet, I close it. The exhaust stops. This is a concept to be adopted for those who normally forget to switch on the exhaust fan when they use the toilet. It is just a concept. It is one of the ideas. So this is only a concept. In practice, this circuitry has to be waterproofed or embedded into the plastic case here itself. So that can be done. That is left to your imagination how this can be used. This is only a demonstration of the concept and not okay. And as of now, we cannot put water or wash this particular thing. Only after making it waterproof using a transparent container, it can be done. So for this I have used this remote control, and this is a homemade switch. It's a gravity switch. You can see the plunger here. This plunger, when it is made vertical, when the seat is made vertical, the plunger plunges and creates the contact. See, like this, right? Again the plunger comes back due to the slant position of the switch, and the circuit breaks and infrared transmission ceases, right? So this was my end product. Well, to prevent damage while cleaning this toilet, to prevent accidental splash of water on the circuitry, I prefer to waterproof this one using a plastic box. This is a lid of a toffee box, plastic box, so through which the infrared rays pass through without any hindrance. And I have tested it. This is working fine. So the system can be hermetically sealed using this box, and I have tested the system works equally well with this. So this is one of the options for waterproofing the system, right?